What's up, what's up, what's up, everybody? Welcome back. Today we are working once again on our neural network training framework thing that we're making for barcode scanner. The intent of this thing is eventually point our phone camera at, stuff on a web page, have it scan the code. You might say that's an easy problem. And I would say there is an easy solution to that problem for sure, but it's not as robust as I want it to be. I keep going back to this guy where even at the store I struggle to scan the egg carton because, it's hard to scan this. It's just there's not like a clean one-dimensional signal. Even with like the laser grid on the fucking self-checkout, it doesn't really do okay. There's other examples, there's stuff like blurry stuff and like, weird lighting conditions, whatever. It's like not like a super trivial problem. So we're like, we'll train a neural network to do it because we're too stupid to figure out how to do it by hand, right? We have a neural network, a couple neural networks that we're working on. Again, the goal of this thing is to run it on my phone in like a video stream, right? So we need this thing to run fast. And we need him to like at least be somewhat accurate. We need him to like at least know if he's inaccurate and hopefully make up for a lot of bad situations. And so we're thinking like we'll do kind of like a two-stage thing, right? First stage, find a box of a barcode. This is like a kind of silly example. We've got like overly perfect hand-generated data, as well as we're just slapping some like bars on top of a background. So the first stage is like find a box. Some of these things are clearly still wrong. Like that's a really bad box. But the second stage of this thing is to do actual parsing, right? So the idea here is that the isolation doesn't need that much resolution, so you can do it at kind of low res. But then once we have the low res thing, we want to like extract that small component of the thing and use like a higher resolution image to actually do the parsing, right? So here's our like example of one that, a network attempts to do this. Again, overly perfect data, easy problem compared to what it would be in the real world, but we're starting to see something that like kind of works. Here we're seeing like this is an example of a thing that parsed incorrectly. There's a couple bars that it got wrong, but hand wavy, it does something. We can start trying to experiment with like a full pipeline flow where we actually do that work, right? And so that's kind of what we started working on yesterday. Is we started writing this scanner app, who takes in our two networks and he starts to generates like the box data, the data for ingestion by the box isolation network at high res, right? This is a high res image. So we can't feed this into like the box detection thing yet. So we tried to like downsample it to low res. This is a downsample, but it looks like shit, right? And so we kind of got a little sidetracked. We went down this rabbit hole where we were looking at Python PIL's library, and we were looking at like, how does it do downsampling? And it creates something that's like a lot more reasonable to me, right? Something that looks more representative of the barcode, and I think more representative of the data that we feed in for like the original network that was trained, right? So we want to do something more like this. And we found that we didn't quite get like the exact answer, but basically if you turn on like bilinear interpolation mode, or I should say resample mode, they call it bilinear resample mode, they do some sort of like pixel averaging. We found that like they're basically doing something that like looked like a Gaussian blur a little bit, right? So they generate this like image kernel that looks kind of like we saw a shape that looked like this, right? So where we had like a bar graph that looked kind of like this, where they're kind of saying like at each pixel, look around you as well. I think we don't have to do whatever they did. We can choose what we want to do. But this looks a lot like a Gaussian blur, right? So we can probably just create a Gaussian blur kernel that like is approximately the right size to kind of like blur this shit down and then resample from that. I think that's probably the play. So the first thing to do today is like finish our downsampling stuff so that it doesn't look like shit. It doesn't have to look great. It just has to look like okay. Once we get there, then we can start like feeding our downsampled stuff into the network. See if it like is degenerate, right? Because it might be that like it might be that the training over focused on some particular things that were like true of the source data, but not of like resampled data, which we might have to fix. Then like try to do box extraction, resample that, and feed that into the second stage network. That's kind of the intent for today. We'll see how far we get. We kind of have a hard cap. I can't really go past 4 today, so we'll see where we end up. I assume the resampling part is the fact that the image is resampled to fit a new size, or they're doing something fancy. Yeah, I think that they're. It seems like they were doing some sort of like convolution, like you said, but I don't really understand the like kernels that they were generated with some sort of logic that depended on like the resample mode. So I don't think it's as simple as just like a Gaussian blur, but we can just do a Gaussian blur and that's good enough. So we could take our high-res image, pass a Gaussian blur kernel over it at like the correct scale, and then resample from that the way we're doing now, where we just kind of like pick the closest pixel. I think that's kind of like shit. I think that that's like computationally maybe more expensive. I guess we should maybe start there as like a ballpark, just to see like if that's fast enough, then it's fine. We don't have to think about it. But if that ends up being slow, then maybe we try to get a little bit more intelligent in our downsampling. Yeah, let's do that. Why make our problems harder than they have to be? He said. It's like that's like a look to camera moment, right? You're like, I would never overcomplicate a problem, guys. We would never do that around here. Okay, so let's go to where's our downsample stuff? It is in the math executor. Where's our like Gaussian blur stuff? I think in the math executor we have like is there like conv somewhere? Conv program content. We have conv many kernel is probably something that we could use. So we have like many convolutions and we run them on many images. We also, I guess we kind of want, this isn't quite what we want, right? Conv many, oh, I see. Then there's like the gradient side. So I guess we kind of want run this one kernel on many images. But again, if that ends up being too expensive, we can just cheat it later. Or cheat it for now. So let's say right now we want to make a blur kernel and duplicate it n times. Yeah, I mean, that doesn't feel great. How hard would it be for us to have like a conv many by one kernel, you know? Is that like something that's easy for us to make right now? Conv many. It would just be here. We throw in like a modulo somewhere or something. Yeah, so this guy's like which conv many index from ID. Right, so this guy's like which image, which pixel am I? And then here, given that, how does he figure out which kernel to sample from? Oh, this is already what we want. Wait, I'm a dumbass. Because he has one kernel that he's running on one stack of images. That's already what this does. This is actually already exactly what I want. I'm just an idiot. I thought it was like run many kernels on many images. This is run one kernel on many images, which is exactly what I want. Sick. Okay, so we just have to like construct a blur kernel then. So let's do that. And we have something already, I think, that generates like a Gaussian blur kernel for our like randomization of bar generation. Right, we have make blur kernels, which samples from many guys, which means that we should be able to just be like make blur kernel with specific params, which maybe should just live somewhere else. Maybe. Where does this come from? This guy's got generate blur kernels kernel, who lives in here. Generate CL. Make. What was it called? It's called generate blur kernels. So this is used in the context of like when we generate like 1,000 images at once. One of the like randomization parameters for the data that we're generating is like how blurry should this specific barcode be, And so that's kind of what this guy's doing. We kind of want something a little different where we're like, we have a concrete amount of blur that we want to apply to one and make one kernel out of that. But like, there is a piece of this that is exactly what we need in here, right? He has sample normal distribution this way, and then run that shit. So we basically just want to pull that part out. So here he's saying like, I am outputting many kernels. I have figured out where my kernel center is and my kernel X, kernel Y. What is the generic part? Then he samples from that like XY based off this. Okay. Okay. So I think we want a function that's like sample Gaussian blur kernel that takes in kind of like, I guess, the X and Y values and the center. What is this used for? I guess just the X and Y and the size. I think. So he wants something that's like, okay, you know, the X, the Y, kernel size. And then hopefully the rest of this is like easily to calculate. Oh, and standard deviation. Right, so something like this. And then we kind of do all of this stuff here. I guess. Yeah, something like this. And volume will not be 1 seems bad. Well, how do we deal with that? When we generate blur kernels, the fuck? That seems bad. Maybe somewhere we must sum and divide. We must. That's crazy not to. Are we crazy? Maybe we're just fucking doing the wrong thing here. Yeah, I mean, that seems bad. When we call into this thing, when we call generate barcode, we have maybe our blur kernels here. Where the fuck do we run this? Oh, mask conv here maybe? So we have our image kernels that come in here. And then when we call mask conv, are we getting clever here where we divide by like the kernel amount at the end? Yeah, I see. I see. I see. That's how we solve it. Okay. Okay. That's kind of strange. And we probably can't get away with doing that same thing. But we'll figure that out later. Okay, so this should be like, yo, hit me with kx, ky, and kernel center, or kernel size. this kind of comes like this. And then here, kernel center should be used here, probably. Okay. Yep. So hopefully, oh, this is the wrong fucking file. God damn it. I'm fucking in some .orig file. That's so annoying. Oh, it's so annoying. We just fucked that up. Okay. It's okay. This hopefully still looks the same. God damn it. I guess what we should do is we should like re-copy paste in case something changed between wherever the fuck that was and now. But I think it was mostly the same. Okay. Okay. Here we go. Here we go. And what are we doing now? Ret is sample Gaussian blur kernel. Okay. Okay, so now if we run, I guess, like image gen here, this should still look, we should see like blurs that look okay. He's mad because, what the fuck? Oh, because we call it K size now. Okay, let's try this again. Let's try again. So the question is do these things still look like the right kind of blurry? I think so. Okay, we should we can test this by doing like default config and just like cranking up the blur. Oopsies. Why does that not work? I think that I've seen before that if these rand ranges are like exactly the same, it doesn't like work the way you would expect. But yeah, I mean, I think that's working. What if we compare this with, like, am I looking at the wrong thing? No. If I compare this with doing like 001. Why does it still look, something's wrong. Something's wrong. I don't know what. Oh, I guess this could be a result of the normalization. That, like, the blur always happens a little bit. Yeah, that's probably a fucking bug. Like, when we generate these blur kernels, when we apply them, we always scale everything. Oh, no, because if we do, like, if we keep, like, the standard deviation range really low, then all of the, like, mass of the kernel should be stuck to the middle. So, like, why is it that if I do, like, change this to, like, 100 versus... Oh, there we go. No, wait. Here we go. It just had to be higher. Okay. Yeah, that's blurring. That's blurring for sure. Okay. So what do we want to do now? We want to use that new thing that we split out to generate one blur kernel for use on the high res stuff. So we're gonna say like generate blur kernel who is still gonna keep the kernel size. He's going to create one of these only. What is min sigmoid and max sigmoid? Yeah, fuck that shit. We're just gonna take in the standard div. No random parameters anymore. Are you implementing columns from scratch? We've kind of like mostly already done that part. So we're just more like implementing generation of a Gaussian blur kernel that matches something that we've already done in the past. But like before we had a function to like generate like many kernels within some range. Now we're trying to be like, let's make one that generates one kernel with specific parameters. So we're just kind of splitting some of that out. Okay, so we have kernel size. So this kernel X and kernel Y are still correct. Is kernel offs... Wait, maybe this is wrong. Because we don't have multiple kernels anymore. We're only generating one. So this is just like global ID here, I think. So we're gonna like, if we had a 3x3 kernel, we'd have 9 elements. This would give us the X and the Y. Great. We have standard deviation passed in. And then we have this here. So we have bing, bang, boom. Okay, cool. And I think what we want to do is actually do this. We have like our float res is this. So this is the like the output for one of the kernel cells. And then can we do like work group? There's like a way for us to like add the outputs that each of these guys together ended up with. OpenCL workgroup functions. As long as this is under the workgroup size, then we're chill. So we should do something that's like, if kernel size times kernel size is greater than get local size 0, then we maybe set like ret global ID to infinity or something, just to make it like really fucking obvious that we fucked some shit up. But this shouldn't happen. And so now we should be in the case where we can do like a work group reduce. So it's like work group reduce add, I think. And then we can say that we have like total is this. And then we can do the like divide right now. And so this thing should be normalized to like a sum of 1.0 automatically. I think that should work. I think. And so let's then, I guess, generate a blur kernel and apply that before the downsample. Sure. Sure. So this has to live in barcode gen right now, which is kind of fucked up, but like whatever. Can we do generate single blur kernel or something? Just like, it just feels like we need some single blur kernel, and then put a fix me here. Should live in math executor, but like whatever. Like this, and now we have to make somebody call it, right? So we're gonna be like pub function, make blur kernel, make single blur kernel or something. Maybe it shouldn't live in the math executor. I don't know. Kernel width. No randomization. So it's literally just kernel width and standard deviation. Which is in like some fucked unit also. I'm not even positive that 1.0 is 1.0, but like whatever. Okay. Oops, can I fucking please yank the right line? Thank you. So our output here is kernel width by kernel width. Easy. Then we execute generate single blur kernel, and we have our output, we have kernel width, and then it was just floats to dev, right? I actually don't remember. Yeah. Easy. Okay, so we should be able to then, in our, like, scanner, take this, like, high-res thing that we made, and we should be able to just, like, fucking fuck that shit up. So we should be able to be like, for now, if we just go math, I guess we have like blur kernel is barcode gen. Make single blur kernel with our allocator, and we need our kernel width, which I guess is like relative to the downsample size, right? So if we have like, if we're downsampling like 10 times, we want to blur over 10 pixels, probably. Kernel width is going to be config data image size out of like high res over this, right? So if this is like 10 times too big, we're going to make like a 10 wide image kernel. Feels kind of right. And let's just do like 1.0 in here for now. Maybe we crank this up to see later, but like we'll try this for a second. And we'll say, let's probably just like tried. And can we just say like conv many? So we're like, yo, run this shit on bars images, which I think might have to be reshaped. Reshaped bars. I think, because I think they're expecting a channel here, which means that we might actually want this guy to be kernel width by 1, because I think he needs input channels as well. And so then he's like blur kernel here. And I think this should make something blurry. Work group reduce add. Maybe I got it wrong. Little underscore, you said? Right. So this is now supposed to be kernel size times kernel size. Kernel elms, and then just calculate this here. Great. Okay. Invalid dims here on conv many. So what does he want? Which line is this? This was at 794. So he's mad the dims length is not, kernel dims length is not 4. Oh, sure. Invalid reshape of, whoa. What the fuck? I'm confused. So he's like, there was 64 outputs, and now there's 1? And this is at 222? Oh, this is wrong. Of course. Conv many, I'm an idiot. Conv many says, I have an input image, and I have maybe like a 2-channel input image, which means that I have like a 3D image kernel that I want to run over M with 2 channels in. And I have like times n of these. And so the output of conv many is like width by height by n, right? However many things you output, because this is meant for like neural network running. Okay. Fuck. Is this really starting? This is starting to sound like not easier than doing something else. We're like trying to do a hack, but this hack is getting like too difficult. God damn it. But it's fine. It's fine. We can make it work. No, wait, hold on. I'm confused again. So if I have 50 images of 50 images of width by height by 2, and I run a kernel over those that outputs 2 channels, then I should end up with like 50 by width by height by 2 again. So where is this getting confused then? Where is this 64 to 1 coming from? It's because when I reassigned bars images from conv many, so ret should be width by height by 1 by n. So we ran reshape bars, width by height by O by n. Okay. I'm back to thinking this should work, which means something is confusing. Blur kernel dims, and can we look at the reshape bars dims? What are our 2 inputs of this thing? Okay, hold on. In kernel out. What the fuck have I done wrong here? In 1024 by 1024 by 1 by 1. Kernel 5 by 5 by 1 by 1. Great. Out 1024 by 1024 by 1 by 64. Wait, that's all right. Oh, this doesn't have to be reshaped anymore. That's why. Oopies. Shit's confusing sometimes. Okay, so I guess the question is, did this thing get blurrier? One, it got darker. That seems bad. I don't think it was supposed to look dark. Right? I don't think that happened, or was supposed to happen. But let's try cranking up the standard deviation of this thing. At least let's see if it looks like... Okay, so that's good. That does look blurrier. If I crank this up like even more... there's a bug in here for sure. There's a bug in here for sure. Where did it look like it worked? What the fuck is going on? What the fuck? Okay. So it's like something to do with the normalization. I feel like with such a huge standard deviation, it should be more blurry. I agree. There's something wrong here, I feel like, but we have to find it. Okay, so clearly the like normalization thing isn't working. Clearly, I just don't know why, right? This total Can we go like res total? This doesn't look like, it doesn't feel like it's working. But I don't know why. Okay. So this guy is doing what seems to be a somewhat even blur. This is 1, 2, 3, 4, 5, 6. I think this is supposed to be 25. And so if we do like just ballpark 0.0038 times 25, we get 0.095, which is an order of magnitude off. Because this is breaking it. This, when we do the like work group reduce thing, we can't early return. Yeah, that's the problem. Is that it's like adding stuff that these guys didn't populate. So I think that you want to do like float res is 0 here. And then if this check passes, then do all of this stuff. And then do this again or something. I think this changes it. I think. Let's see. Okay. Fucking shadowing. God damn it. Fucking shadowing. Yeah, so that looks way better, right? The total now is like correct. So let's just double check those like workgroup functions. So return of redirection is specified by op for all values of x specified by work items in a work group. For example, blah blah blah. I mean, it doesn't. Yeah. Oh, all these built-in functions must be encountered by all work items in a work group exiting the kernel, right? So what I don't understand is, do they have? I guess it has to be the one at that line too, right? Yeah. So I guess it does kind of have to be like this, which is kind of fucking weird. But fuck it, I guess. Okay. Cool. So that looks a little better. So now can we crank up the standard deviation a little bit? Oh wait, is higher standard deviation? Higher is more blurry, I think. But it could be that the blur kernel size is limited. Yeah, so if I put 1 here, we see this, right? Very kind of harsh edges. And then I crank this up to like 100. And it's definitely blurry now. And then how does like our like resized version of this? This looks a lot better already, right? You can already tell that this looks more reasonable. Now, I think to match what they were doing, I think that I wouldn't be surprised if there's like a ×2 in here or something. Yeah, or maybe they weren't doing Gaussian blur. So we can kind of tune this into like a way where it makes sense. It doesn't really matter that much. I think, let's just see, does this like look reasonable the way it was? I guess is the question we should ask. Maybe I would go a little. So if we crank up standard deviation, that's basically makes it a box blur. And I think that basically my gut says that this is like still too harsh. So my gut says we make the kernel width higher and we lower the standard deviation so that it kind of, we can like let it spread a little bit farther. So here we're just like, okay, crank this up to 10 now, and let's see how that looks. Okay, there we go. That's like closer. I want less than that though. I mean, even that's too much, I feel like. That looks pretty good to me. Can we compare this with if we just run image gen on this thing and like create these guys directly? I guess this is what it saw when it was creating. So we could do something that's that harsh. Right, like this type shit. Oopsies. So really, we don't have to get this aggressive. And really going less aggressive is probably good. So can I go back to smaller kernel size again? And let's just see. Maybe it was fine. Right, that might actually look like what it was trained on. Image gen. Oh my god. Oh my god. Fine. Image gen. Okay, does this look okay? Like, does this look the same? Is the question. Yeah, I would say that this is fine. I would argue that this is probably okay. Maybe it's like a little bit more than this particular one, but maybe we can find one where it's not. Right? Like this is like pretty harsh. This has like the kind of like the same pattern that I see here. So I think that's okay. I think I'm down to leave it like this. Because this is a lot better. Again, let's compare to the way it was before. Which I guess would be like if we put a standardization that's like so small that it's basically irrelevant. I think that's the easiest way to like, kind of simulate that for now. Yeah, here we go. Right, this is what we were getting before, which is absolutely fucked. Right, so I think that I'm happy to say that this is good enough. Good enough. Good enough. Fuck it. Fuck it. All right. Holy fuck, that was 40 minutes. Jesus. Okay, let's try to load and run this network now. So we haven't loaded it yet. So what do we need? We need like a checkpoint probably for this thing to load from, which we're not passing in right now. Stage 1 checkpoint. These labels are wrong, it's fine. Okay, so we need a stage 1 checkpoint. 1 checkpoint. Bang, bang, boom. Config checkpoint. Okay. And checkpoint here. All right. And I guess we need it here as well. Okay, so once we have this thing, it should be like, we want to like load that thing and create a neural network from it. So we have like NN somewhere, a module called NN. And here we should have some sort of like NN. How do we do this in our main app? Layers. Model from config is what we call. Let's kind of just see where this goes. So here we don't need to use our tracing executor, so we can kind of try that and see what happens. Initializers needs to be there. So this is like NN initializers. Make initializers. Okay, nice. Technically, we don't need these because we're not randomly initializing, but the API needs it, so like kind of fuck it, I guess. So this is like, give me one of these and a ran source. Okay, great. And then we need the checkpoint. So where did he get checkpoint from in this? like this. So this is arg's stage 1 checkpoint. Okay, which means that we need an end checkpoint here. Okay. Cool. Let's just see if this like builds, I guess. And can we bring this down like here somewhere? All right. Let's just see if this builds. It does not. Because this has hard-coded tracing executor here. Here we're not using the tracing variant, so that should be fine. This is mad because there's like some pointer shenanigans going on here. Yeah, true. I guess we'll just make it mutable. I think that makes our lives easier. Okay, so that compiles. That's good. Which means that we should be able to like run this model, probably. Probably. I don't know, man. Run layers. All right. And we're running it on, I guess, our like resampled images, probably. Sounds kind of right. And we pass in our layers, I guess. And this guy's got a hard-coded tracing executor in there, which is wrong. We want to be able to run this on any type of executor. Executor here is one of these guys. Yep. And then we're like, run this shit on any executor and return us an execute tensor. Okay. Looking good. And we just have a few types to fix here. Oh. No, this is running only on traced. Wait, that's bad. I guess we'll make a new function here. Run layer is untraced for now. And we just won't do that part. So we'll... I don't know, man. We'll see. I don't know. I don't know, man. And can we just return one of these? Okay. So here we're like... This is our batch. Then we execute this thing with math executor here. Okay. And then we return results, I guess, and just see where this goes. Okay, cool. So we're like, run layers untraced. And this is boxes, I guess? I guess. I don't know, man. Let's just see if that runs, I guess. Compiles, does it run? So we need our stage 1 checkpoint, comes from demo, stage 1, network, checkpoint, spec. Okay, there we go. Okay, so that's a good sign, is that it runs. Now, whoa. That's a bug I haven't seen before. If I click on the scroll bar right on the border here, or I click on the scroll bar then drag off. No, if I click it right on the border, there's some sort of bug where it thinks I'm also dragging the image view. That's trippy. Look at that. That's crazy. Okay, so I guess what we should do now is we should try to draw the box on top, right? I guess maybe we should just like log the boxes. Math executor to CPU. I'm pleasantly surprised that ran at all, to be honest. Pleasantly surprised. All right, what do we got here? How's this bad boy looking? Those are numbers. I don't know what I was expecting to see here. Okay. I guess we need to like render this thing on top. So we need to be like render box. We have something here. Training sample view. Make bbox GL buffer sounds kind of right. So we're like, okay, we're gonna like make some sort of bounding box thing. We're gonna put you on some allocator, and then we're gonna render that thing. How do we do this in main? Train UI maybe. We have like a scratch buffer. We take the image that we are rendering, and we like slap this. Oh, this is the wrong thing. Hold on. This. So we like take our OpenGL allocator, we make the bounding box, and we just call render line strip. Yeah, that seems pretty reasonable with this like image render context. Yeah, I mean this is the same shit, I think. That seems reasonable to me. So let's say this is the wrong file. Scanner. We want something that's like render box on image. Sure. And we are like, we have this image that we are rendering, which is a texture, GL texture that we're rendering on top of. So that would be, we create this image view here, and we have, it's got to go in here, tensor to image view. Yeah. So here, we must have like the box as well. I don't know. Sure. How did this work? He takes in a box here. Okay, cool. Wait. Oh, I see. Okay, cool. I think I understand. So we can probably just do this inline here, to be honest. Fuck it. Okay, so we get image view, image here. This guy needs a scratch GL, which comes from GL alloc or something. Okay. Then this is the box. Okay. And we need like a solid color renderer as well, I guess. I don't know. This render, like this comes from what? XYT program, solid color program or something? For me, bbox is 4 cores per image x, but we've already seen the logs is more than 4. Yeah, but it's like 5. It's actually 5 because there's rotation, and it's multiplied by the number of images that we're generating for, which is like 64. So it seems like not necessarily wrong. Okay. Color red or something? Sure. And so now everybody, we call this like tensor to image view thing. We need box and like GUI state solid color render or something like this. So that means that like we have kind of like all the boxes kind of pulled out here, but we need like box as a slice of F32 comes from boxes at what's it called? It's the displayed image ID times 5, and we have 5 things. Something like this. Okay, so far looking good. Which means that this stuff has to come up here. God, there's so much like disaster happening. Okay. So we have like a box. Cool. And can we just kind of slap that on top for now? On both of these? And I hope everything's in normalized units, so it should just render on both okay, I think. But I don't know. I don't know. Everything is just kind of there, and we're just kind of seeing where it ends up. Hello? What's he pissed about? Expected 8 arguments, found 7. Oh, I forgot scratch GL probably. Yeah, I did. Fine. If you're gonna be like that. Index out of bounds. Oh, because it's actually by 6. It's actually 6 of them. I forgot. Okay. Wait, that's kind of good. So that is a box rendered on top, and in the high-res image, we do see the same box, which is good. Which is good! So that means that we've like loaded our network and run it, and it's run successfully, and we have kind of like a mapping of data onto something more sane. That's great. That's great. So I guess that means that the next thing to do is to try to like extract this thing from the high-res data. Which involves, I guess, like a resample here according to this rotated box. I guess, something like that. So I assume we have this like downsample thing. I guess we like, this is very close to the same code. It's just where it's downsampling from is like in like another space. So can we, for now, kind of, can we, how do I want to do this? I guess we want like, I'm just gonna copy paste this for now. I'm sure there's a better way. I just don't want to think about it. Okay, so he is like, yo, I've got some in images, I got some out images, great. And then I also have some like boxes. And this is like definitely like fix me, like should definitely either take a better box representation or not live here. These are our 2 options, oopsies. But I don't know which one of those it is yet, so we'll deal with that later. But our boxes, so we have like in images is in width, in height, channels, num images. Out images is outsize by channels by num images. Okay. And then our boxes is 6 by num images, where the representation is x offs, y offs, square root width, square root height, cos r, and sine r. This is like what we see here. Okay? So the question is now, what do we do with that information? Our resampling right now is saying like, come from in images and let me look at this like input x and input y. So I think that we're very close here. It's just we have like 3 spaces now, right? We have output space, which is like x, y pixel in out image. We have box space, which is like x, y pixel, but relative to rotated space or something, right? And then we have like in image space, which is like take box space and unrotate and offset or something, right? So like if we're resampling, our like normalized space is like x, y pixel in out image normalized from 0 to 1. We take this normalized thing and we use that as offsets into the box space or something. Is this used anywhere? No, we should get rid of these as well. So it's like we take x box is x norm times box width, I guess, right? So I guess here we want probably like box is boxes at global ID times 6. Because we have 1 box per output image. Great. So that means that here we have like box 2 times box 2. And y box is the same thing, because these are square roots that we're seeing here. We have like our x, like box x-axis here is just the box 5, box 4, and 5 here. Right, this is the orientation of the code, I think. And so our y-axis is just like an inversion of that. And so we should be able to be like, take my x in image, right? Or in x, we should call this. And this is going to be like the box center x times the in width, because the center is in like normalized space. But this is offset from the center, right? So this has to be in width over 2 plus that to get like an offset from the center. He doesn't like in y. I don't know what he doesn't like here, so we'll ignore that for now. He takes the in width over 2 plus the box thing, and then we say like no, this has to be a float too, somehow. Box center. Box center, like in the input space. In box center. So this is like box 0, box 1 times in width times in height, offset by in width over 2. I don't know, man. That feels like kind of right. Okay. So like what the fuck do we do with this? We say like in x is the in, I guess like the I guess it's like in pixel as a thing is like the in box center plus box x axis. Yeah, there's something here. Times x box plus box y axis times y box. Right, so This is from the center, though. We probably want this like top left relative. Oh my god, this is so hard. This is so hard. Why? So we've got like something like this in some input space where like I have some box pixel that I want to sample. I want to sample from right here in box space, which means in image space, we have like the center here plus this plus that, right? Essentially, which seems fine. But this, so we want our normalized thing to be minus 0.5 here, I think. So we're like minus 0.5, like where are we relative to the center? This is like relative to box center. Which box pixel do we want? That feels kind of right. That feels kind of right. So then we have inbox center plus this, and then we just like floor that shit. In pix 1, in pix 0. I mean, there's like a non-zero chance that that's right. I mean, he seems to think that there's like compiler errors here, so clearly something's wrong. I just don't know what yet. But I'm not entirely against it. Maybe he's mad that these aren't uints. Yeah, that's what he's mad about. Okay. I mean, that's like maybe. That's maybe. Let's play around with it. What do we call it? We call it downsample. Let's call it downsample from box. Fuck it. Fuck it. Okay, downsample box. And if this works, I'm gonna like be shocked. I tell you, shocked. Boxes is, I forget what Linux distro is. This is NixOS, but I don't think it really matters, to be honest. And so I think the only thing we added here was a boxes buff, right? And he uses downsample box. And then everything else is probably like the fucking same. I guess we should also check boxes. Dims len is not equal to 2. And if boxes dims 0 is 6, then we have a problem there as well. And then if boxes dims 1 is not equal to in dims 1, then there's also or 3. There's also a problem there. Probably they need to have like the same number of shit. And then this is downsample box here. All right. Non-zero chance that this works, but I would be shocked. I would be kind of shocked. So how do we want to do this? We want to go into scanner, and we want to take these boxes, and we want to say like extracted is math executor downsample box from cl alloc bars images boxes, so boxes, and target size, which is, I guess, for now I'm just gonna write like 600 or something, but fix me pull from stage 2 config is what should be happening here. And then I want to show that thing. So we need like another image view for extracted, right? And in here, we're like, hit me with the extracted image view. And then we also want to throw that thing on here. And he is taking extracted like this. And then here, we don't want to render a box on top. So that means we need to make box optional. And then here, down here, we say like, if box B, throw that shit in here like this. Okay. How we looking? This is mad because I put the fucking question mark in the wrong spot. Fine. If you're gonna be like that, you're gonna be like that. This guy does need to make it here. Okay. And let's just kind of see what happens here. I bet you something crashes. Yeah. Seg vault. So can we, at the very least, guard this thing a little bit? If in channel, can we do like in index is this thing? And we'll say if in index, I guess we'll do this. In index is less than I want to do something else actually. In channel offs, I want to call this is this. And we say if the in channel offset, i.e. the XY position in this input is less than in width times in height, then we do this. So we say channel times channel size plus channel offs. We do this. Give him the image that we're looking for. Otherwise, 0. Let's kind of start there. And I'm sure that this is going to cause problems, but at least we shouldn't like fucking crash anymore. Right, we shouldn't be like touching memory that isn't ours, but we are, which is interesting. In, out, boxes. Let's just double check that we got the order right. Fuck. What are we doing? It's fucking math executor. So in, ret, boxes. In, out, boxes. Okay. Boxes dims is 6. So box is boxes plus global ID times 6? No. Global ID, this is wrong. This is over outsize. Over outsize. To get our index into which image we're in, maybe even over channels, right? Because we have one box per output image. Okay. That might have been it. Okay. So, good news, something's here. Bad news, it's not what we want. But we did get something. Okay, let's start here by saying like if global ID is equal to 0, let's just print off the box just to make sure. 1, 2, 3, 4, 5, 6. Let's just see if this makes sense, right? Box 0, box 1, box 2, box 3, box 4, box 5. We'll start here. We'll start here. Okay. So I guess we should check if that matches what we see. I mean, we can actually kind of like eyeball it, right? So it's like a little bit to the left, a little bit to the left, a little bit towards the bottom. So like 0.07, 0.16. Yeah, sure. And then his rotation is like, he's pointing like left and a little bit up, like mostly left, a little bit up, which matches up with this line here. And then the width here is he's like a little wider than he is tall, which I think also matches up. So I think that this is likely correct. Not like we don't have like 100% there, but it looks like likely that we're reading the right box at least. So that's good. Can we start looking at our X, Y box stuff? So can we say, so let's start, if we were just look at global ID 0, we should see that this is the top left pixel. So we should be sampling from the top left of the box, which would be negative 0.5 doubled up, right? So can we start there? Let's say that we're going like, this comes from this. So this is out X, out Y comes from X box, Y box. Let's see if these coordinates make sense. And these are like this. Okay. Okay, so that's good. Right, negative 0.5, negative 0.5. This is wrong. This 0.5 should be here. It should be, the 0.5 is normalized space, not box pixel space. Okay. The box width and height here are also kind of fucking wrong. The width and height here need to be multiplied by the input width, I think. Because this needs to be like pixel space in the image. Fix me. Non-square aspect will fuck this up. Almost certainly. But let's just try that for now. Can we just say, like, if in width is not equal to in height, can we just do, like, global, like, ret out images global ID is equal to infinity and return or something? Let's just, like, fucking not get out of here. Because something will be wrong. Oh, hell yeah, look at that. That's a fucking extracted box, dude. So this box is slightly over-rotated counterclockwise, which means that these things should be drifting right. That's sick. Wait, that's kind of right. And then we're looking at the blurry image, though, so we need to unblur that stuff. We need to unblur that. So can we do blurry bars? Let's just kind of do this. We won't reassign bars images anymore. And then we'll resample the blurry bars here. Yep. And then when we're downsampling the extracted box, this is, I think, fine to do at high res. Someone's mad about bar images reshaped. We have to fix this. So these need to have a channel, like a number of channels, which is 1 because it's grayscale, but he needs to know that that is that way. Oh, which we have. We have reshape bars. Where is this used? We just need to use this down here too, probably. Reshape bars. Okay, there we go. It's a little bit like fucky-wucky here on like the resample. So maybe we should apply yet another blur here. Maybe. Because like there is going to be also like some like warping of this thing. Eventually this output image should be not square. But for now it has to be. So like kind of fuck it, I guess. Kind of fuck it, I guess. I wonder... Okay, so we should probably dilate the box a little bit, to be honest. Because I think that's kind of more in line with how it was in training. So can we kind of do something here? Like we take the X and Y box positions, and these are offset like here, X norm minus this, and can we just like multiply this by like 1.2 or something just to like dilate the boxes? Will that kind of do what I want it to? I think it will, but I'm not 100% sure. Yeah, so that just kind of like zoomed this picture out a little bit, which is hype. Maybe that was like a little bit much. Maybe a little 1.1 would be good enough. Yeah, that looks pretty good. And so that's probably a like good enough image to run our like network on, I think. So can we run the stage 2 network then? Okay, so we need to load the second stage network again. So the same, oh, we also have to, yeah, we haven't opened the stage 2 config or anything yet, so we'll figure that out. So this guy, he's got to be like stage 2 config, stage 2 checkpoint. Here, can we start looking at this? Stage 2 checkpoint, stage 2 checkpoint. I think my argument parser, it's hard. Like, I know that there's some sort of like mega duplication in here, but I don't know like what it is, to be honest. Like, the fact that I'm like copy pasting this and going like as stage 1, stage 2, like, obviously that's wrong, but I haven't really figured out where I want it to be different. You know? Because like I do believe that like the flexibility of the each argument being like its own like thing is nice. But anyways, stage 1 config here is the thing we've parsed so far. So we kind of just everywhere we're using stage 1 config right now, we do that. And then we can also just parse the stage 2 config up front in the same way, which obviously is duplicated. This is prototype mode. Don't judge me too hard. Only a little bit. You're only allowed to judge me a little bit for this absolute fucking shit show. Okay, so where was this thing? First of all, this was stage 2 config, data, image size was what we wanted to use here. Only a little bit of judgment. Hell yeah. Hell yeah. Okay. So we need to load in the same way that we loaded our stage 1 thing. This is all like stage 1 now, right? So we kind of do like stage 1 like this. We have a stage 1 checkpoint. I guess initializers is global. That's fine. But we have stage 1 checkpoint here. And so I guess we have the same thing here where we have like stage 2 checkpoint and stage 2 layers, which comes from stage 2 checkpoint and stage 2 config. But everything else is probably like the same. And so like after we've extracted this stuff, can't we just run like, I think we just run this on the extracted, no? So we have like bars, like predicted codes, I guess, is run this thing on stage 2 layers. And then can we like look at this shit? So like for predicted code CPU from 0 to 96, 95, I don't remember how big these are. Can we just like print that? I think it's like std debug print. Can we just print that like a number that's like if p is greater than 0, print 1, else print 0 or something? Just for a second. That seems reasonable. If we can survive the masters of judging. Okay. Dude, I know that they're painful. My math is like so not good, but rude. Okay, how dare you? How dare you? Can I say I want this to be a U32? All right, there we go. You're past the stage 1 checkpoint to the stage 2 layers. Yeah, so true, huh? This is why copy pasting is bad, by the way. I do this all the time. Where I'm like, I'm taking a shortcut, and the shortcut's just like wrong. All right. Hello? Oh. I forgot to put this in squigglies, of course. And then we need stage 2 checkpoint. Comes from demo stage 2 network checkpoint spec. We which is interesting when we load the checkpoint. So we are loading this thing with CL Alec. Can we just like up this guy to like 100 megs of memory? I don't give a fuck, dude. I don't give a fuck. Take 100 megs. Take all you need, buddy. That's surprising. Oh, maybe the checkpoint's like fucking huge, actually. I think it might be. It is 315 megs. All right. That would do it, huh? So now we have like some dimension shit. Okay, so what's going on here? He's like, yo, you can't reshape this 32 by 32 by 8 by 64 thing to 80,000 by 64. Yeah, where is that coming from? I mean, that is just true. So what the fuck have we done wrong here? Are we passing in the wrong... we're probably passing in the wrong images. Probably, right? So we're like, yeah, predicted code should be extracted, not resampled, you dum-dum. Okay. Okay, so now the question is it right? 0, 1, 0. So, okay, 0, 0, 1, 0, 1, 1, 1, 0, 1, 0. This one may be wrong. Oh, hold on, maybe it's backwards? Is it left or is it going left or right? Oh yeah, you know what? If this is upside down, it doesn't work. It does like it won't work because we only ever showed it right side up once during training. So if this happens to be upside down, which it is, I think maybe it's like it has like some like hard coded like, oh, I learned this way and it is always this way. So can we temporarily do this? Config hacked. And let's just say that our angle offset here, or like rotation range, should be oh, that doesn't even fix anything though, because the prediction is allowed to predict either way. The box prediction is allowed to go either way. Okay. So we're just gonna have to fix that. But for now, let's just try flipping it and doing both. So can we do something that's like flipped boxes? Is something? Checksum solves all that. Yeah, but we have to at least try both directions to get the checksum. But yeah, I agree. Yeah, okay, we'll do this. Barcode gen should have a function that's like flip boxes. And he's like, here's my boxes. And he is like, I'm gonna return a thing that has the same dimensions as my input. And we're going to run this for I guess not every element. He's gonna be like, I guess get one, the outer gem. So we're gonna here like std debug like if boxes dims len is not equal to 2, we have a problem. Ginger, come here. Hey, come here. Dog's a little antsy. Get over here. Yep, all the way. Thank you. Good girl. Yep, all the way in. Let's calm down, okay? Come over here. Good girl. Okay. So this guy, he's like, if it's not the same, then we have a fucking problem. I guess we check if the first dimension is not equal to 6, then we have a problem as well. Cool, so now we're running this n times. And this is like here, and we're running flip boxes kernel here, and it's literally just like boxes and output, I guess, and however many boxes there are. Okay, and so now we need like a flip boxes kernel. Okay, and then we have, you know, this again, and this again here. Cool. And so we just need like this guy to have flip boxes. So he takes in and out. And if global ID is greater than n, then we freak out. True. We have thread in, thread out comes from in and out. Okay. And so we just have like thread out is thread in for 1, and then 2. Hold on, this is fine as well. So the width and height are all the same. It's these output vectors get flipped here. Yeah. Cool. That like might compile and it might run. We might get both of those. Okay, so now we probably just want to run this on the flipped boxes as well. So here we want to be like extracted flipped. And we run the second thing on extracted flipped, I guess. Not really thinking it all the way through. We'll see. Flipped. 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 And then we do this flipped as well. Easy. Okay. So the question is one of these correct? We should probably fucking print some new lines, huh? Probably. Okay, fuck off. All right, what are we looking at? He needs some time, he's thinking. Okay, so we need to decide if we think one of these is right. So we think 0, 1, 0. 1, 1, 1 is more likely to be the correct one. So then he's like, I think 0, 1, 0. I guess that's fine. There's no way this is right. Absolutely no way. Unless, okay, let's try the other one. Can we like also render the flipped one as well? Let's just double check that that like did what I think it should do. So extracted flipped here. And then we render that thing as a widget in our UI. And then wherever the fuck we set that thing, we do the same thing with the flipped one. Using flipped here. All right, let's see. Fish PR got merged? Hell yeah, dude. Let's go. All right. Okay, so that's fucking wrong. That's fucking wrong. Right, so what the fuck did we manage to do there? We must have really fucked up the boxes. We must have. Zero, 1, 2, 3. Oh, I guess we just started missing 4 and 5. Like, we did 5 and 6 instead of 4 or 5, like dumbasses. Oopies. Shouldn't you keep the cosine the same when flipping? I think that we're just trying to invert. Like, if this thing is pointing up and to the left, we want it to point down and to the right. So I think you just invert both, I think. Yeah, here we go. So this... Interesting. Oh, it's because it's stretched. There's some, like, warping going on here, too. But is this, like, the upside down thing? Yeah, here you can see, like, this little, like, section here matches this on the bottom here. This right section matches this left section. So it is the upside down version, which is good. which means that like this maybe we get lucky here. 0 1 0 1 0 0 0 1. That's kind of like this. I'm gonna do a keep on top here. Right, so that's this 1 here. 0 0 1, so that's this. Matches this. 0 1 1 1 0 1 1 1. Then we're on here. 0 0 1 1 0 1 1 0 0 1 1 0 1 1. I think this is right. 0 0 1 1 1, so that's this. Matches this. 0 1 0 0 matches this. Then 1 1 1 0 0 1 1 1 0 0 1. Hell yeah, dude. Let's fucking go. 0 1 0 0 1 0 0 0 1 0 0 1 0 0. Fucking let's go, baby. This is 1 0 1 0 1. Whoa. 1 0 1 0 1. So that's here. Is this? Okay, looking good. Double zeros, double ones, double zeros. That's this. Then a little alternating. That's this. Matches this. Quadruple 1. Shocking, but that's here. Then 0, then 111. So that's this. Then 0 double 1 0 double 1 double 000. Ooh, that one of these is wrong. Yeah, this is 0001 instead of 0011. But then the rest of this is probably right. 0010, that's this. Then we have 11100. This 1011 0 111 010. Yeah, I mean that's pretty good. There was one wrong, but I mean our network isn't perfect. So this is good indication that like there is like this works, right? So we for the first time have gone from arbitrary barcode in image to parsed code. The code is wrong, but like this is the first time that we've like run the whole flow. And so that's pretty exciting. So there's like pretty clear we need to like what like obvious things that need to be done here. Just like looking at this is obvious things that need to be fixed is like stretched code is very warped, right? So there's something fucked up looking about this where like we assumed vertical stretching would be okay, right? Because if the bars are like basically perfectly upright, then it would just look like you extended the bars, right? But when there is rotation involved, it does not look like anything we saw in training, right? Because it's like parallelogrammy, so we need to like fix that. We need to have like some way, so we need like some procedure to pick which rotation we liked better, right? That's important. Also, this thing is like obviously running pretty slow. It feels like maybe like non-square image inputs might be interesting. So maybe if like the majority of this is like convolution based, you might be able to get away with kind of a non-square aspects. Maybe there's like maybe a way to do that. Not sure. But yeah, that's pretty sick. So now that we have this, we can like once we have like a couple better networks, we have like a thing that we could feed like a real picture into, which is very exciting. And then obviously like this is not very helpful. What would be much more helpful is like statistics on how well this performs as a whole over like a big image set or something. But that's for later. The code is obviously shit. It's like code is mega shit. So we need to fix that as well. But hell yeah. Happy with that. Probably like box dilation as well. Is like maybe needs to be adjusted a little bit. Not sure. But overall, I'd say that's a success. Cool. All right. Happy Saturday. Thanks for watching, guys. If you like what we saw, we stream most days. We aim for 12:30 to 4 o'clock Pacific time. It is just before 4 o'clock now. Yeah, last 10% problem. Yeah. Probably more like last 50%. So if you're watching live anywhere between, 4 hours ago or 3.5 hours ago and now, so you just go to see us. Check the YouTube if you want to keep up on the project. Consider supporting on Patreon, YouTube members, Twitch, whatever, if you want access to the VODs that we don't post, as well as knowledge that you're helping the streams survive. Otherwise, later, Gata. I'll see you guys. I might see you tomorrow. It depends on if I'm hungover when I wake up. So we'll see tomorrow if I'm like willing to get on camera. But if not, then I'll see you Monday. All right. Let's find someone to raid.